In the spring of 2011, areas along the Mississippi River were devastated by flood. Record high levels of water flowed swiftly towards the delta. In Louisiana, levees and flood control structures prevented widespread flooding. However, the system also prevented the river from delivering much-needed sediment to the delta's rapidly disappearing wetlands. Although these structures performed as planned and prevented disaster for millions of residents, this flood was a lost opportunity to reconnect the river with its wetlands and to rebuild rapidly disappearing coastal marshes. I am Susan Cantrell for the National Wildlife Federation. The Mississippi River drains over one-third of the continental United States. The river and its delta are an economic engine for our nation. Starting at the old river control structure and the headwaters of the Atchafalaya River to the Bird's Foot Delta 100 miles south, the Mississippi River Delta accounts for more than 25% of waterborne exports and nearly 40% of our nation's seafood. This is what the Louisiana coastline looks like now, but it didn't always look this way. For 7,000 years, the channel of the Mississippi River has snaked across the coastal plain, flooding its banks in the spring to gradually form the deltaic lobes that pushed into the Gulf. Each time the river changed course, it left behind thousands of acres of new land. Over thousands of years, the river built our modern-day coastline. The river once spread across a vast network of distributaries. Together with natural levee breaks called crevasses, the river was integrally connected to its surrounding wetland. Levees protect cities and industry from flooding during high water periods. However, this system has a high cost to the region's ecosystem by limiting the connection between river and wetland. Following the flood of 1927, the Army Corps of Engineers constructed the modern-day levee system, stretching more than 2,200 miles along the lower Mississippi and Atchafalaya rivers. One by one, the natural distributaries were cut off, no longer able to provide fresh water and sediment to the wetlands. In the early 20th century, the delta consisted of large expanses of healthy marshes. However, starting in the 1940s, thousands of miles of canals were cut. Canals and pipelines provide a direct channel for salt water to flow deep into the freshwater marsh, causing the deterioration of a balanced coastal ecosystem. The rate of land lost through erosion, subsidence, and sea level rise is increased with the repeated encroachment of salt water. Louisiana's coastline is disappearing at the rate of 1 football field per hour. Left unchecked, the Louisiana coast will look very different by the year 2100. The wetlands of Louisiana face an uncertain future, but the good news is that we have solutions. By diverting sediment-rich water in strategic locations, we can replenish coastal marshes while providing flood control. Newly created and restored wetlands will improve habitat and provide recreational and economic opportunities. At high river stages, when maximum loads of sediment are moved, these diversions will be used to capture flows currently lost into the Gulf of Mexico. The Myrtle Grove Diversion is the first of these projects designed to build land. Since receiving congressional authorization in 2007, the Mississippi River Delta Coalition and the state of Louisiana have completed extensive data collection and modeling to thoroughly understand the processes and dynamics of the river near the diversion site. Sediment-laden water passes through a control structure into a channel. The sophisticated engineering allows officials to closely monitor and adapt the operation to account for proper salinity levels and prevent backwater flooding. When the river is at a low water stage and little sediment exists for land building purposes, the Myrtle Grove diversion will operate at a minimum capacity or not at all. But during the Mississippi's high water stages, like during the record flood of 2011, the diversion could be operated to maximize the sediment flow into the surrounding wetlands. Using a pulsing river diversion allows us to maximize the energy of the river to push sediment into the ecosystem. This diversion process will begin to backfill hundreds of miles of canals and thousands of acres of former wetlands. Over time, this threatened environment will develop into a resilient ecosystem. When the river is flowing high and the diversion is open, sediment enters the ecosystem and is deposited. Once high water recedes and the diversion is closed, the sediment remains. As the diversion is operated over time, new land is created. Eventually, new vegetation forms and the wetland emerges. The combination of marsh and submerged aquatic plants continue to trap sediment and retain the newly created wetlands. The Myrtle Grove Sediment Diversion Project will reconnect the Mississippi River to its delta and maximize the delivery of land-building sediment to wetlands and marshes. As it creates land and fills open water, the diversion will increase the coast's protection from hurricane storm surge and build habitat that supports a diverse and sustainable coastal Louisiana.